Hi everyone, and welcome to your first pre-recorded lesson for Math 1700. And today we're going to be starting translating English phrases into algebraic expressions, which means basically turning keywords and words into math that we can solve. And then we're going to solve some word problems involving one unknown. So let's get right into it. First of all, when we have English phrases and we want to make them into terms of math, we need to look for keywords. What that means is that certain words mean certain mathematical operations. So if we look at this table here, the first set of words will mean plus. You can pause the video and take a time to look through that list. The next set of words mean multiply. So sometimes it'll be a x, sometimes it'll be a bracket, sometimes it'll be a dot. The other set is subtraction, so decreased by, minus, less, things like that. And then division means we'll have the division symbol, or we'll have, I'll say A over B, but really it means a fraction of some sort. That's what those words mean. Finally, if something says equals, well, look at that list, try to make sense of which words would mean equal to. For example, is, are, was, were, will be, gives, yields, sold for, things that are equal to something else. So let's get into a few examples and how to use this stuff. So on the next page, we have translate each phrase into an algebraic expression, which means turn it into letters and operations. So in the first one, I see the sum of 8 and y. The sum means plus. If you don't know why, go back to the previous page and figure that out for yourself. The sum of 8 and y, which means we have 8, we have y, and they're being added. So this is the algebraic expression that the words are saying. And you don't need an equal sign here because it is just an expression, it's not an equation. And there are two different things. The next question says we need to make a phrase for 4 less than x. So this one's really tricky. When you see the word less than, the 4 less than x, you kind of have to read it backwards. It means that if you have something, you have 4 less than that something. So we actually read it backwards. So we have x, whatever that amount is. We have 4 less than that. And so we kind of read it backwards. If you were to write it as 4 minus x, you're actually not writing it correctly because that means 4 minus something, not something minus 4. For the next question, a number decreased by 1, we have some mysterious number to subtract 1. Decreased by means minus. 1/2 of a, well, we have an a, and we've divided by 2. Or we have 1/2 of a, which means 1/2 multiplied by a, or we can have a over 2. They all mean the same thing. That would be the exact same result. 1/2 of means 1 over 2, or divided by 2. The next question, a number increased by 4. We have some mysterious number, and we're increasing it. We're adding 4. Increased by means plus. And for f here, the quotient of x and 3, quotient means divide. So if x and 3 means the quotient or the division when x is divided by 3. The next question here, G, is a little bit of a special one as well. It says subtract x minus 3 from the product of 3x and 8. So this is tricky. Take a moment to think about it. What do we need to subtract? Well, subtract means minus. We need to subtract x minus 3 from the product of 3x and 8. So we actually need to start with the product of 3x and 8, and then we'll subtract x minus 3 from it. So let's start here. The product of 3x and 8 means 3x and 8 multiplied together. So those things. And then we need to subtract or minus x minus 3 from that. But there's lots that we need to do here to keep track. We need to actually add our own brackets. So the product of 3x and 8, we're going to force that into its own group. And then x minus 3, we're going to force it into its own group. And when we read this off now, should be able to get the proper result. We are subtracting x minus 3 from 3x times 8. We could simplify that expression, but we're not going to here. And the final question, H, 20 decreased by or minus from the sum of a number and 6. The sum of a number and 6. 20 decreased by that. So we have 20, and then it's decreased by something. What's that something? The sum of a number and 6. That's a number. Add 6, that's the sum of a number and 6. So to break it up, This is the sum of a number and 6, the number 6, and this is 20 decreased by that number. Of course, this is our 20. All right, and that's how we do these problems. So hopefully you took some time to let that sink in. Go back and try the questions yourself if you need to, or go find similar questions. But we're going to move on to solving word problems involving one unknown. One unknown means that we're solving for example, just x or just y, nothing else. And to solve word problems in one unknown, we have a series of steps or a procedure we're going to follow that you're going to want to try and memorize, or at least fully understand. So the steps are as follows. You need to read the problem carefully. That sounds silly. I mean, obviously you need to read the problem to do it. Many students skip over some of the words. So we do a complete reading to obtain a general idea of what's going on, a general overview. Then we reread to try and figure out what the finer points are. Then we determine what's required and use a variable to represent an unknown quantity. Usually that's our x. Next, we translate the word problem into an equation. That's what we did on the previous page. By the way, this is page 19 right now in your notes. Then we solve the equation, and then we're going to try and interpret the solution or figure out what our final answer means, and we'll check our answer. So let's try a question here. You can try it yourself if you like, example 1. And if you want to pause the video here and try it yourself, your answer that you should come out with is -10. So see if you can do that. In the meantime, I'm going to work through it. 6 more than twice a number is -14. What is the number? So let's check out some key words here. We have 6 more than something, 6 more than twice a number is -14. Is means equals, and -14 is just that number. So what is the number? Let's try to translate this into math. 6 more than twice a number. So we have twice a number, twice something x, 2 times some number x. 6 more than that is -14. You can see that we've managed to translate it into math. So 6 more than means +6. Twice a number means 2x, and hopefully you can see that these things come together. Let's solve this. We need to bring the x to the other side. We end up with 2x equals -14 minus 6. That means 2x equals -20. And then we're going to divide both sides. I'm just going to make myself some more space here. Divide both sides by 2, like we've done before. You get x equals -10. And you need to remember that at the end of this, you need to state what that x means. So all it means in this case, the question was, what is the number? So the answer would be the number is -10. And at the very end of this step here, at the very end of step 5, it says check the answer. So before I check the answer, let me reread, make sure I've done everything. 1, I read the problem carefully. 2nd, determine what's required. Use a variable. I use the variable x. 3, translate the word problem into an equation. So I kind of did step 2 and 3 at the same time. 4, I definitely solved the equation. And 5, I've now interpreted my solution by stating the final answer. And now I'm going to check my work. So to check my work, I'm going to put a check here. I need to put that final answer back into the original expression. So look, the original expression was 2x plus 6 equals -14. So 2x plus 6 equals -14. Let's put that x in. What was the x? It was -10. Multiply that left side out. That gives -20 plus 6 equals -14. Is that true? Well, yeah. -20 plus 6 is -14. That definitely equals -14, and so our answer is correct. Take some time to go back through that if you need to. Question 2, I would now like you to pause the video and try for yourself. The answer that you should get is 49. So take a moment, pause the video, see if you can get that. I'm going to put my final answer up here now, and you can check it against your own, and I'll do a similar problem in number 3. Okay, so my final answer is written as you can see it. You can pause the video and work through it yourself and see if it compares to yours. Question 3 is similar, which is why I let you do number 2 on your own. But if you need a little more support, here we go. Colleen bought 2 TVs and received a $125 discount. If her bill came to $2,045 after the discount, what was the original price of one TV? So I need to set up a variable here. I know what I need to do. I need to try and have the cost of 2 TVs reduced by $125. That would give a a final bill of $2,045. So what we're going to do here, and this will become common practice, we're going to let x equal something, and really x should be the thing we're looking for, which in this case is the original price of one TV. Okay, that's the original price of one TV. So if that's the original price of one TV, we need to work everything out. By the end of this, we're going to get x, and that will be our answer. So she bought 2 TVs and received the discount. So she bought 2 TVs at the original price, so 2 times the price of one TV is that cost. And she received a $125 discount. A $125 discount means you're subtracting it away, right? So that's why these match up. Once you've done that, once you have the 2 TVs, you get your little discount. The amount of money that ended up being paid is $20.45. And so we've set up this is by far the most important and most difficult part of this problem, would be to set up the original equation. So take lots of time, pause the video if you need to try and figure out why I did what I did. If you have questions, write them to the side, and you can ask me them when we're live in class, or through the Teams, or through email. Let's solve this equation. Bring the 125 to the other side. We're going to add it then. Gives us 2170. If we divide both sides by 2 now, divide by 2 and divide by 2, for example, the final answer here is going to be 1085, or 1085. That's actually in dollars because of the way the question is set up. So remember, we need to interpret the solution in terms of the problem. What was the question? What was the original price of one TV? X is the original price of one TV, and we've got X. So this is the original price of one TV was $1,085. Now that sounds great, that sounds reasonable, that's roughly the cost of a pretty decent TV, but we're going to want to check our work, because if this check doesn't come out properly, we actually know we don't have the right answer. So we put our x back into our original expression. 2 times that x, so 2 times 1,085. We're going to subtract 125, and we should get 2045, but we don't know yet if it is. So I'm going to put a little question mark there. 2 times 1085 is 2170. And take away 125, and again we're going to see if that's equal to 2045. And if you subtract that out, you indeed see that it does. That's 2045. The right side is 2045. They're equal. So it checks out, I'd like to say, and that means that our question or our answer is almost definitely correct. So go back through and watch that again if you need to try and solidify these ideas here. Number 4, I'm going to let you do yourself. The final answer that you should get is 21. So pause the video and give that question a try, and then I'm going to post the solution here, which you can look through yourself. And here we go. So the sum of 3 times a number and 9 is 72. The sum of 3 times a number and 9 is 72. You work it out, you end up getting the number 21, and you can check it. And it turns out that it does check out, so that's a big fat green check mark on that one. Let's move on to page 20. So this is express several unknowns in terms of one variable. So this is a little different, but not that different. Let's see what's different about it. It says Sherry's salary is $4,000 more than Hillary's. Express Sherry's salary in terms of Hillary's salary. So Hillary's salary is kind of like the key here. We want to express everything in terms of that. So that's a good key. That actually is telling us that we should let our unknown x be Hillary's salary, or what we're referring to, or what we're relating it to. And then once we know that, we can relate everything to that, we can reference everything to that, or compare it to that. We should be able to get our answer here. So let's read the beginning here. Sherry's salary is $4,000 more than Hillary's. Okay, well Hillary's is X. This must be Sherry's. Sherry's is $4,000 more than Hillary's. So we've actually done it. We've expressed Sherry's salary. This is Sherry's salary. Oops. Sherry's salary. X plus 4,000 is Sherry's salary. We've expressed it. That's actually all there is to do. The question is just to express them, not to solve them. So B, the length of a football field is 30 meters more than its width. Express the length L of the field in terms of its width W. And so I'd like you to think about this one yourself. Pause the video. Think about what your expression would be. And then see if it works out to be this. Where W is the width, and L, or length, is of course the length. And it says I needed to express the length in terms of its width, which I did. Width is what I start with, add 30, and I get length. I'll do C more fully with you. A wire is cut into 3 pieces. The first piece is 2 centimeters less than twice the length of the third piece. The second piece is 10 centimeters longer than the third piece. So if you just read it the way that this is written, it can be very confusing. It kind of is a bit of a tongue twister and definitely hurts the brain. So let's try to figure out what we can do. What's being compared to here? Well, a wire is cut into 3 pieces. The first piece is 2 centimeters less than twice the length of the third piece. And the second piece is 10 centimeters longer than the third piece. So really what everything is being compared to is the third piece. So I'm going to just write that down. Everything is compared to the length of the third piece. And the reason that this is relevant or important is that we can make that our x, because then everything will be related to it. So let x, this mysterious number we're looking for, be the length of the third piece. Okay, and now that we've got this set up, we can try to make our expressions one by one. A wire is cut into 3 pieces. Okay, gotcha. The first piece is 2 centimeters less than twice the length of the third piece. Try to take that sentence. The first piece, 2 centimeters less than what? Twice the length of the third piece. So 2 centimeters less. Sorry. The vacuum got turned on. 1 second. Sorry about that. Got totally distracted. Let me just read it out again. The first piece is 2 centimeters less than twice the length of the third piece. 2 centimeters less than twice the length of the third piece. And that is as far as we need to go. That is the length of the first piece. Why can't I write? I can't spell. And then, okay, let's do the second part. The second piece is 10 centimeters longer than the third piece. That's actually an easy expression. The second piece is 10 more. So we have the third piece's length. We add 10, and we get the length of the second piece. Now I've written this out fully for clarity, but really if you just wanted to write length of the, and then write second piece, you could have just written the quotation marks just to save yourself a bit of writing, but it's good to be complete. Okie doke. Well, D, I would like you to try. Read the question. See if you can do it. I will do the question out, but I'd like you to do your best. See if you can write out what you think the answer to this is. Okay, hopefully you've paused the video and at least gave it a shot. Maybe you've already solved for it, maybe not. But in any case, you should be trying to do this yourself as you go. The measure of the first angle of a triangle is triple the second angle. The measure of the third angle is, I don't know what's up with this of and is thing, is 15 less than the second angle. Write an expression for each of the angle measurements. So let's try to figure out, is something being compared to here? Well, yes it is. The measure of the first angle of a triangle is triple the second angle. So we're relating it to the second angle. So really, it's the second angle we're talking about that we care about. The measure of the third angle is 15 less than the second angle. Once again, being related to the second angle. So the big key, everything is being compared to the second angle. Similar to that previous problem, where everything was being compared to the length of the third piece. So we're going to let x equal the second angle, or the measurement of the second angle. And let's go bit by bit, see if we can figure out the expressions. So the first statement, the measure of the first angle of a triangle is triple the second angle. So 3 times the second angle is going to be the first angle. So we've made that expression. That part's done. The measure of the third angle is 15 less than the second angle. So 15 less than, remember that backwards thing, we have to have an angle first, and we take 15 away. That's the measure of the third angle. So these are the expressions you should have gotten. Really, it comes down to these expressions here. 3x, or 3 times the second angle, is the first angle. X minus 15, or 15 less than the second angle, is the third angle. So it's easy to get kind of tongue-tied on this when you're talking about it, and especially when you're thinking about it. Take time to try and let this sink in, and redo the questions if you have to, and I'm sure you'll get better at it. That ends today's lesson. Make sure you cover all this and try to practice yourself before the next lesson. Thanks, everybody, and we'll talk to you soon.